Hello everyone, this is the third part of educational material prepared for undergraduate students, and it is about fundamental of heat engine. The learning objective. After this presentation, the students are able to explain heat engine, classify heat engine using different parameters. The content. The content of this presentation material are heat engine, internal combustion engine, and external combustion engine. Heat engine. What is a heat engine? Any type of engine or machine which drives heat energy from the combustion of fuel or any other source and converts this energy into mechanical work are said to be heat engine. Heat engine may be classified into two main classes as follows: external combustion engine and internal combustion engine. The internal combustion engine is shown in picture A, and the external combustion engine is shown in picture B. Heat engine. Let's discuss about the further classification of the engine. The internal combustion or ICE engine. So the internal combustion engine is sub-classified into reciprocating type and rotary type. Under the reciprocating type of the internal combustion engine, we have spark ignition and compression ignition engine. The spark ignition engine is again categorized into petrol and kerosene engine and gas engine. The petrol and kerosene engine are also subcategorized based on their cooling system into air cooled and water cooled. And again, such type of engine is further classified based on the number of stroke. So we have 2-stroke and 4-stroke. And the 4-stroke can be again classified based on the valve gear mechanism, the overhead valve, the side valve. And the compression ignition engine is the oil engine, and it uses diesel oil, and the cooling mechanism is similar to the spark ignition engine, and also the number of stroke or cycles are also similar. So there are 2-stroke and 4-stroke compression ignition engine. Let's come to the external combustion. The external combustion engine is sub-classified into reciprocating type and the rotary type. Under the reciprocating type, we have reciprocating steam engine, and this reciprocating steam engine can be simple, compound, or uniflow. The other category of the external combustion engine is rotary type. And the rotary type of the external combustion engine, we have a steam turbine. And this steam turbine can be classified as radial flow reaction turbine and axial flow. Let's see the detail External combustion engine. The combustion of fuel takes place outside of the cylinder. These engines are generally used for driving locomotive, ship, generation of electric power. So this picture shows the locomotive external combustion engine powered and operated on a rail. How does this work? So the steam engine is to work. There should be a coil to produce fire or to heat up the water. So the water in the container is boiled by the coal. So the burning coal heats the water. And when the water boils, the steam is produced. And this steam leaves the water container and enter into the upper part of the piston. So when it enters the upper part of the piston, it pushes the piston downward. So the force required to push the piston or to move the piston is created by the steam pressure. So the movement of the piston is transferred to the crankshaft by using the connecting rod. So what makes it external combustion engine? The combustion process is took place outside of the engine. This is the engine, and the combustion process is taken here, just very far away from the engine. So such system is said to be external combustion engine or ECE. The example of the external combustion engine are a steam engine, hot air engine, a steam turbine, and closed cycle gas turbine. The different type of engines are shown here, which indicate how the external combustion engine work. So here, this is the container, and it is full of heating medium, and there is heat source here to heat up the substance inside of here. So the substance heat mean the pressure on the substance is increased. So this piston or this part move. The movement of the piston or this part transfers to the crankshaft by the connecting rod. So the rotational or mechanical power is generated here. And similarly, here you can see electricity can be generated by using the steam energy. So water is stored here, then the stored water move to the heating medium. So the boiler or the burning gas here generate heat, and the water boil or expand and pressurize. Then this pressurized water, that means steam, push or turn the turbine. So the force applied on the turbine by the steam generate a rotational power on the generator. So when the generator turn by the steam energy, it produce electric energy. So the steam energy is also used to generate electricity. Internal combustion engine. In this type of engine, the combustion of the fuel with oxygen of the air occurs with the cylinder of the engine. So in the internal combustion engine, the combustion process would be take place inside of the engine.
When a piston travels to the end of its range, whether up or down, that's a stroke. Car engines use a 4-stroke cycle, and it goes like this. First, intake. The piston descends, sucking an air-fuel mixture into the cylinder through the intake port, with both intake valves open. Next, compression. With all valves closed, the piston comes back up, compressing the fuel and air mixture for more powerful combustion. Then, the power stroke. An electrical spark ignites the compressed fuel and air mixture, and the resulting combustion forces the piston to the bottom of the cylinder again. A connecting rod transfers this power to the crankshaft. Finally, exhaust. The piston comes back up, pushing the spent mixture out through open exhaust valves and the exhaust port, connecting multiple pistons. For smooth power delivery, pistons take turns firing. The firing order for this engine is 1, 3, 4, 2. Camshafts with specially shaped cams push spring-loaded valves open in turn. Cam gears and a timing belt or chain links everything to the crankshaft, and it all spins together. The crankshaft translates piston power out of the engine. It has counterweights to balance against the pistons for perfectly smooth revolutions.
Advantage of reciprocating internal combustion engine over external combustion engine. Reciprocating internal combustion engine offers the following advantage over external combustion engine. Overall, efficiency is high. Greater mechanical efficiency. Weight to power ratio is generally low. Generally lower initial cost. Easy starting from cold condition. These units are compact and thus require less space. Advantage of external combustion engine over internal combustion engine. Starting torque of the external combustion engine is generally high. Because of external combustion of fuel, cheaper fuel can be used. Even solid fuel can be used advantageously. Due to the external combustion of the fuel, it is possible to have flexibility in arrangement. These units are self-starting with the working fluid, whereas in case of internal combustion engine, some additional equipment or device is used for starting the engine. Application areas: the internal combustion engine. Type: gasoline engine. Application: automotive, marine, aircraft. The gas engine. Application: industrial power. The diesel engine. Application: automotive, railway, power, and marine. Gas turbines. Application: power, aircraft, industrial, and marine. External combustion engine. The type and the application. The steam engine. Application area: locomotive and the marine. A Stirling engine. Application: experimental space vehicle. A steam turbine. Application area is power and large marine. Closed cycle gas turbine. The application is in the power generation and also on the marine. Thank you for watching this educational material. If you are interested, please share with your colleague. Thank you.